Yo, what is good, dev guys? It's your boy K. Yes, sir. I'm back with another video. In this video, I want to start my series where I start going into the Unreal Engine documentations and doing video counterparts of these quick start guides. Unreal Engine has a documentation full of quick start guides, intermediate guides, and advanced guides to help you learn different features of the engine and different parts of the engine a little bit better. So I want to dive into the documentation and get a better grip on the engine. And unfortunately, all of these tutorials are written tutorials, and me, I am a visual learner. I can take written tutorials, but it's taken me years to get the patience to do it. So I want to create video counterparts for people like me who prefer to have a visual reference in front of them while they're working on a tutorial. So we're going to jump into MetaSounds. Right now in my project, I am currently messing around with MetaSounds, learning about it, using it for like weapon firing and stuff like that. So I want to reinforce my learning by teaching this. So we're just going to step through this quick start guide. There's also this reference guide. I'll leave a link to this in the description of this video. This just goes over majority of the nodes that are inside of the actual MetaSounds blueprint. So let's just jump right in, man. I'm gonna go to Unreal Engine 5. That's where MetaSounds lives. You can only do this in Unreal Engine 5. So I am going to start a third-person project, blueprint, and I'm gonna call this my quick start guide. And this is where I'm gonna just hold all of my quick starts or advanced or intermediate tutorials. So I'm gonna create this project. Okay, right off the bat, we want to go ahead and hit this manage plugins button here. And I want to go and type in Meta, and I want to activate or enable MetaSound. And this is going to tell you something about it being unstable. It's in beta, it could be removed, but I'm pretty sure going forward, the future of sound inside of Unreal Engine 5 is going to be MetaSound. So I'm gonna hit yes. I'm not scared. I'm gonna restart the engine now, and we'll do some house cleaning or some basic setup here in a sec. Okay, I'm gonna close this down. I'm gonna come over here to my content folder, right click. You know, I love to have things organized. I'm gonna create a dev folder, and it's good to have this folder mainly because of source control. Like you can literally tell Unreal Engine to or your source control to ignore every other folder except for this dev folder where you are actually creating things that can't be recreated unless you remember them. We also want to just go in, and I'm going to select all this stuff in the level, not this. Deselect that. And I'm going to delete all that stuff. Delete that as well. And inside my dev folder, I'm going to make a new folder called MetaSound. Just go in there. I'm going to right click, go to sounds, and create a MetaSound. Now the nomenclature for this is MS underscore and whatever you want to name the sound. This is going to be procedural music. And I'm going to save that. I'm going to also create the blueprint actor that we're going to have in the level as well. That's going to allow us to drive the MetaSound via blueprint logic. So I'm going to create a blueprint class actor. We're going to call this BP underscore level music. We're not going to mess with that right now. We'll do that after we finish with the MetaSound. So double click, open up the MetaSound, and let's introduce you guys to this editor here. This is your blueprint window, the typical blueprint window where you add nodes. You right click, you can add a node, select and delete nodes, right click, hold down to pan and zoom in and out with your control, with your scroll wheel. And if you hold control, you can zoom in a little bit further, get more resolution there. Moving on, we have a few tabs over here. This input outputs, this is kind of like your variables and your functions here. As we populate this graph with inputs and outputs, you'll see this get filled up. And this is basically where we will hold our variables. Usually there's like a my blueprint that holds variables, but for MetaSounds, it's these inputs and outputs here. You have this toolbar here, so you can save the MetaSound. You can browse to it in the content browser. Hit play or stop, you know, those are straightforward. But you got your general settings here. These are kind of like the settings that you would have in a sound cue where you can set up the master class for the mixer, the attenuation. You can set up a sub mix over here and different things like that inside of this general tab. And then the MetaSound tab, this is particular to the MetaSound. It can change it from mono to stereo. You can also add like data assets, user data. I'm not sure how this comes into play. Haven't seen anything about it yet, but you can if you want to. So last but not least, we have this meter over here. This meter just keeps track of your decibel levels and how the sound is acting, whether it's clipping or reaching the desired decibel levels that you want. On play, this is kind of like begin play in a blueprint. On finish is kind of like end play. And this output node, this is the final place that all of your audio needs to end up if you want it to be played. So that's the introduction of the MetaSound editor. And let's move on to the first step where we actually start creating some nodes here. So first step is to right click and go ahead and search for a node called trigger repeat. Now this trigger repeat node, this is basically like a loop. Okay, so it'll go through, it'll finish all the way through the audio, get the audio pushed out, and then come back depending on this period, how long it'll take in between pushing out this audio and coming back and repeating. So this period, we're gonna set this up. Let me plug this into plug this on play into start here. We're going to set this up based on BPM, which is a beats per minute. So if we go in here and pull off that and type in BPM 2 seconds, you'll see this node will pop up. This node basically just converts beats per minute to a seconds float value that we can use in this trigger repeat node here. And we also want to pull off of this bad boy and promote it to a graph input. This will allow us to control this BPM value outside of this graph. So let's go ahead and rename this to BPM. And you want to make sure you give these things smart names, man, because when you're adjusting these values outside or inside of a blueprint that's not this MetaSound blueprint, you have to pass in a name of the value or the attribute or the variable that you want to adjust. So one other thing is we need to change this divisions of a whole note to 16. This is just how many breaks exist in one whole note. If you adjust this, you'll see that you'll get different variations of music by adjusting this whole note divisions. Okay, last part of this is we want to drag off from this repeat out and do a trigger counter. Now this trigger counter, it is basically saying for however many value that we put inside this reset count, which we're going to put in 8. So once this counts 8 times, it'll trigger this node, this pin here, this on reset. And that on reset will do some logic, and this on trigger will do some logic every time as well. So let me add a comment around these. This is our tempo and rhythm. Be able to adjust these values as we see fit. I'm gonna drag these over here, create a little space. Let's get that. Okay, so now we need to pull off of this on trigger here, and we want, every time this is triggered, we want to get a random float. So it's random get float array right here. And we want to pull off of this in array, and we want to pass it a scale. So we can say scale to note array right here. So basically this will say whatever scale we pass in, major scale is C, D, E, F, G, A, B, C. It'll say, all right, I'm gonna make that many array indexes based off of this major scale here. So we'll have a index for each note in the scale that we pass in here. So of course, we want to be able to adjust this outside of the graph here. So we're going to pull off of that, create a input, and we're going to call this scale. So I hate that you can't do F2 to rename inside of here. There's a few things that are weird about this that they haven't implemented yet. Like you can't add reroute nodes just yet. Hopefully they get that, you know, settled in Unreal Engine 5, the final version or the release version. Now we want to get a random integer to feed into this seed, and that will basically change the index layout of how each of these notes are being played. So if it's seed -1, which means basically no seed, we're doing the straight C, D, E, F, G, A, B, C note index, and 0 is C, and so on and so forth in order. But when you change the seed, it will rearrange those notes. So maybe it'll be A, C, D, B, A, you know, something like that, to give you a different variation in the melody. So let's drag off of this and get a random int. And we want to do a value in between 0 and 100,000. Why 100,000? I'm not entirely sure, to be real with you guys. But we definitely want to pass this in. And on this, from this next pin, we want to pull out and we want to promote this to a graph input, because we want to trigger this random integer whenever we feel it needs to change. So let's go ahead and just call this melody. If I could select this melody. Last but not least, we want to go drag off from this value, and we want to add a float to it. And this will just add, like say we're on index 0. This will add a value to that index so that we can convert it to a hertz value that we can use as a frequency. So let me plug in 48 here. I'm not sure why they use 48. Maybe it's a magic number in music, but we can adjust this to see what happens if we change it. So this node group here, this is our melody creation. This is where we create the melody. So I'm gonna go ahead and drag and move these over a little bit more. Now we want to actually create some sounds. So let's go ahead and get a sine node here. And if I grab this sine node and I plug it to the output, you'll hear that it's this it's just a tone. If I press play, it's just a tone there. And we can basically adjust this tone using effects and filters and stuff like that, so it can make a different sound. Basically, all sounds in digital audio workstations are based off of a sine or a saw, or something like that. And then it's just filtered and adjusted to sound like a real world instrument. There's also real world instruments, of course, but let's move on. We want to drag off of this add node, and we want to change this from MIDI to frequency. And this node here, they have a very good reference guide. I think I spoke about it earlier. You can basically come in here and search MIDI, and you can look up the information that you want to know about each node. So this MIDI to frequency, it converts a float or an integer MIDI note input to a frequency in hertz using the standard MIDI scale where C equals 60. These notes are used to musically control generators that take hertz as an input, and the floating point version can take a fractional MIDI note values, which is useful for microtonality and custom tuning. This is just letting you know what this is doing here. And that's a good reference to have when you have no idea what's going on with these nodes. So definitely hit that link in the description to have that open as a reference. I won't be reading every node's information. I'll leave that up to you guys to reinforce your own learning. But moving on, we want to drag this out frequency and pass it into the frequency here so that we change the frequency based on our random seed or our random note here with this plus this value, and then eventually give us a frequency that'll be converted into a note. So we want to do another one of these. So let's select these and Control W to duplicate them. And we want to take this value and add another float to it. And this will allow us to change the tune or the tone of the frequency that's coming through from here, and kind of like detune it or raise the tune, raise the octave or lower the octave by passing in a value here. So we can pull out here, and we want to edit this outside of the graph. So let's go ahead and make it a input, and we're going to call this detune. And remember, I said make names that are going to be easy to remember, because you do have to pass these names in through via the blueprint that you will be adjusting these values from. So let's pass this value into here. And now we have our synth sine set up. So this is the sine synth. So let's go synth dash sine. And one other step for this is we have to add this audio together so that they play well with each other. They kind of merge together. This is kind of like layering a track on top of a track inside of a DAW, where you layer one track on top of the other track. It basically just does that for you. And you can control the gain or frequency if you want to for this. Like you can drag off of this and mix it if you wanted to and put it in after you control the gain, do something like that. But we're not going to worry about that. We need to do this logic here again, but for a saw synth. And I'll play a saw for you. So if I go here and type in saw, we'll get this note here. If I press this into the output, be careful, this might hurt your ears. This is kind of a little bit more harsher sound here. So that's the saw sound. It's a little bit harsher. And we're going to have this for variation inside of our procedural music here. So let's take this out frequency, pass it through here. We need to get this value as well so that all of these notes match up to each other. We want to get the same basic, we want to get the same foundation set up here. So take this value and pass it into here. And then we need to duplicate this node and pass the frequency into here. And this is our synth saw, synth dash saw. Whoops. And we also need to add this audio together. Whoops. Add these two bad boys together. There we go. So now we just set up our two synths. Now we want to set up a crossfade feature to where we can crossfade in between this synth and this synth here. So go ahead, type in crossfade inside of your graph here. Right click, type in crossfade. And we want to fade in between this audio that comes out here and this audio here based on this crossfade value. So if the value is 0, we'll be playing input 0. The value is 1, we'll be playing input 1. If it's in between, it'll be something in between. But mostly you just want to fade completely to the other audio. So I'm gonna pull off of this and we want to control this outside the graph. So we'll make it an input. Let's call this crossfade right there. And that's pretty much it for the crossfade. So I'm gonna go ahead and add a comment, call that crossfade. And now we want to do some filtering here. This thing called ladder filtering. Now, filtering is kind of like taking the sound and chopping off the bits that you don't want in the sound. So for example, if we go and right click and type in ladder filter, right now the cutoff frequency is 20,000 hertz. This is kind of like the sound. If you ever listen to 20,000 hertz, this is like the sound that makes, you can barely hear it, to be real. But if you can hear it, it makes you, it weirds you out. We want to actually change this by using the LFO, which is a filter oscillator. And this will say, okay, we want to give you a minimum and maximum value. So anything lower than this value, cut it off. Anything higher than this value, cut it off. And the frequency, we want to set this to 0.5. The minimum value, we want to set it to 500 hertz. So anything lower than 500 hertz is kind of like rubble noise. And anything higher than 5,000 is kind of like too sharp for the ear to basically be comfortable to hear. You know what I mean? This is kind of like, I don't want to say it's like compressing, but it's like EQing. This is what we're doing here. We're EQing the sound, equalizing, if you don't know what EQing is. For you music majors, you love this stuff right here, man. I remember I was making music and trying to learn about this type of stuff. And music is literally a science, bro. It's crazy. Music is a fucking science. It's beautiful. So we're going to plug this into here. We're going to plug this out value of the crossfade into this filter here because we want to filter whatever audio comes through. And we want to just go ahead and create a comment around this and call it our filtering. And that's it for the filter. You can also add more things if you want, like compression and stuff like that. depending on how you want sounds to operate. But we'll just stick with the quick start guide here. So moving on, we want to go back to our our random get flow array node and pull out from this on next. And we want to get this node called AD envelope audio here. And this is basically going to create a, how could I say this? It's going to create a lerp from the input and the output of the sound. So that it'll kind of not crossfade, but it'll fade in and it'll fade the sound in and fade the sound out. So it's not coming in stomping on your ears. You know what I mean? If you don't do this with some sounds, it'll stomp on your ears, and you kind of want it to flow in. So some of the settings on here, we need to change the decay time to 0.01. And then we want to multiply this value by our filter value. So let's get a multiply audio node here. And this doesn't have reroute nodes. I got to drag it out over here like this. So we want to multiply this envelope against this filter here. And that'll set up our filtering. I'm sorry, that'll set up our envelope. So I'm going to just put a comment around this. It's our envelope. And I want to move in and create some space here because we need to add a few more nodes. From this node, we want to create a slight delay. And this will just add a little bit more volume by offsetting the sounds a little bit. Very small, 0.02 is the value that they give you, but you can play with this to see what you actually want. Now, we also want to drag off and get a stereo delay. And this will basically play the delay in both ears. And we want to set the delay mode to ping pong, which will bounce it in between the left and right ear. And then we want to set up some settings here. So the delay time is 0.2. The delay ratio is 0.2. The dry level is 0.7. The wet level is 0.2. And the feedback is 0.4. So you can go in and look at the reference guide to see exactly what all of these values do. Most likely you'll just play around with them and see what they do. See what kind of effects that they give your sound. But we're going to pass this value into the right ear here. So that's why we wanted to delay this sound just a slight bit here so that it kind of gives a feeling, more filling in the ears. So let's create a comment around this and call this effects processing. Whoops, I spelled processing wrong. Procession. Okay. And now we want to plug this output into this output node here, but it's mono. So we need to go to the MetaSounds and convert this to stereo so that we get the correct outputs. So let's drag in the left into the left and the right into the right. And I forgot to pass in this on reset here. We want to reset the random get float array so that it'll reset this array of nodes here back to the first index. So if we save that and we go ahead and press play, you'll see we'll get some pretty cool stuff popping off here. Yeah. And this is all based off of the BPM here. So if we change the BPM, everything will change. So if I go 60, it's a little bit different. Okay, and now if I change this divisions of a whole note, you'll see that it's kind of a little bit slower. So if I change that and press play again, it's real faint. I don't know if this is loud enough for you guys to hear. I'll turn the audio up just so you can. But yeah, it's real like slow. Imagine this being the metronome. So put this back on 16. Press play. And I actually want to go in and I want to change this detune from, actually the base default value is supposed to be 6. But I like to detune it to 12. makes it sound a little like it's real. I don't know how to explain it. It's kind of like an X-File sound. It's kind of weird. I believe something is messed up. I'm double checking. Make sure we got everything set up properly. Yeah, that's pretty much it there. Okay, let's change this 48 value and see what happens. Let's change this to 60. Okay, this changes the octave. So we can go up if we want. That sounds really sci-fi. Put this on 48 back. This is pretty cool. I feel like something's messed up. Because technically it's supposed to sound like this. So I've messed something up here to where this sound is not playing how it should. So let me step through this again. Let's just double check our work here. So from the beginning, we create that trigger repeat, and we pass in the BPMs here. They defaulted to 90. From there, we create a trigger counter that resets at 8. And then we get a random float array right here. And we pass in the scale to note array, and we adjust the scale outside. Next, we create a new melody, and it's a value from 0 to 100,000. And we pass that into the seed. From our random get float array, we add a value here. That's that where we add 48. And that's pretty much our melody generation there. Now for our sine synth, let's see if we did anything wrong here. We take this value, we pass it into the MIDI frequency, and we pass in the frequency into the sine frequency here. We do that same thing for this value and the detune value. Pass that into the frequency here, so that's correct. And then we repeat the same steps for this saw audio here, to give us that. Then we move on to the crossfade. Crossfade takes in the two audio here. The value is defaulted at 0, so it should be playing this audio first. And then we move on to the filtering. Let's see, did we miss any settings here? We use the ladder filter, and we set the frequency to 0.5. Set the min value to 500, the max value to 5,000. The resonance is at 6. So those settings look good. And then we got the envelope back here. We set the decay time up. There it is. Decay time is 0.1, not 0.01. And let's see if we get the sound that we're supposed to. Yeah, there it is. So now you see adjusting this decay time will basically lerp the sound a little bit faster, and it's a little bit harsher, I guess. Let me see. Let's go. Let's do 3. Yeah, hold the fucking phone. That's hard. Okay, so yeah, we got something going here, man. That sounds good. I might leave that on 3. That's like some good menu music right there. Okay, so now we're going to actually use that blueprint class that we created earlier, and we're going to drive some of this logic inside a blueprint. So let's go ahead and jump into this blueprint class. First thing we want to do is add a box component or a box collider. This will allow us to track overlaps. So I want to jump into the settings here of this box and set the scale on X to 5, the Y to 5. And then we want to come up here to this and set this to 350. That'll move it to our far left here. So, you know, X is forward. So this will be on our far left. Then I want to add a text renderer so that we can know what box this is. We just reset the values here and set this text value to BPM. And whenever we enter this box, we will do something pertaining to BPM. So let's duplicate this here. Duplicate this text render as well. Drag this on top of the box 1. And let's put this at 0 on the Y. And let's change this text renderer to melody. And whenever we enter this, we'll adjust the melody. So one more time, duplicate this and duplicate this text renderer and drag it on top of this box. And now let's set this to -350 on the Y so that it's on the far right. And the text for this is going to be crossfade. So whenever we jump into this one, it'll adjust the crossfade. I'm going to drag this bad boy into the scene already. So we have it, and I'm going to turn it towards the player here. Go ahead and save everything. I usually like to put save on compile on success only, so I don't have to keep compiling and save and stuff. It's annoying. Last component we want to add, of course, is the audio component that's going to hold our Metasound. So add that and navigate over here to sound, and we want to pass in our Metasound procedural music. And now if we go ahead and press play, yeah, that's dope. You can hear the sound playing automatically here. And you can also set it up inside of your Metasound to start this sound only when you trigger it. So if I want to create my own trigger so that the sound starts when I trigger it, I can just pull off of this, create an input, and then drive it that way. But we'll just leave it where it is. So go back to this BP level music, and let's take all these boxes and set this hidden in game value to false for all 3 of the boxes so that we can see the overlaps inside the level. And now let's go ahead and create the logic for when we overlap each box. So starting with the BPM box, I'm going to navigate down to the events and get the on component begin overlap event here. And then same thing, click on that and get the end overlap. So we want to do some logic here, but we only want to do it once. So get a do once node here and then pull off of this end overlap and get a sequence node and plug this first one here into reset. And now for the logic for this BPM, we need a couple of variables. So we want to create a float variable that's called new BPM. And of course, it's a float value. And then duplicate this, and then let's do default BPM for when we reset. We want to reset it back to the default. And I believe inside of our Metasound, our default BPM is 60. Whatever your default BPM is inside of the Metasound, you can go ahead and pass that in. We'll pass in 60. And a new BPM, I just want to double it so it moves twice as fast. And all we're going to do for this to change the BPM is grab this audio component, get it, and then we want to get the parameter interface. This is an interface that lives on audio components by default. And if you have a Metasound inside of the audio sound value here, this component will be valid, or this parameter interface will be valid. And we'll be able to pull off of this and set a float value. And remember, I said you have to pass it in by name. So let's pass in that BPM name. And we want to go ahead on completed, drag in to this set float node. And for the BPM, for the value, we want to pass in the new BPM. And when we exit the overlap, we want to basically do this same logic here. But instead of passing in the new BPM, we want to pass in the default BPM. So I'm going to delete that. And now let's test this out. So if I press play, you hear it. And if I jump into this, it'll speed up. go back out, it slows down. So you can see how you can kind of create tense situations depending on where the player is in the level. Maybe a place in the level has a shit ton of enemies and you want to let the player know, hey, you need to get hyped up for this fight. You're about to have to fight. So you can start playing the music a little bit faster. So that's it for the BPM. I'm going to put a comment around that, call it BPM. And now we want to move on to the melody, which I believe this one is, melody. So let's navigate to the events section here on component begin overlap. Select it again and do in overlap. I hate that it like focuses out of the details. Like I just want to be able to bang, bang, you know what I mean? And not have that. That might just be like an Unreal Engine 5 thing. So when we begin overlap, we still want to do this once. And when we end overlap, that's when we want to reset this. So for the melody, what we're going to do is basically send a new value to the seed here. And remember, the way that we set it up is via a trigger. So we're going to call this trigger, and that's going to send a new value to the seed parameter here. So let's go ahead and get these nodes here. We need to get the parameter interface, and we need to go ahead and trigger our trigger by name, which is melody. And that's pretty much it for the melody. It'll be pretty hard to hear the variation, but you can kind of hear it. So I'll demonstrate it. So let's go ahead and test this out. Compile, press play. And if we go here, you'll hear, you listen to this sound. It's like, if we go in here, it'll change that. And every time we go in, it'll give it a different random seed. And that's the proceduralism there. We're using the same notes, but different, they're playing at different times. It's pretty cool. Yeah, you can see how that could be cool. Allow for one simple sound to be converted, like to make it sound like it's a bunch of different layers and tracks there. So moving on to the crossfade. Let's go ahead and create the on begin overlap and on end overlap events. And for this bad boy, we're going to need a variable, a Boolean as a trigger, because we want to basically decide on whether or not we have set this to false or true on what float we want to send. So let's say crossfade for the value here, or for the name, and for the value type, it's a Boolean. And basically want to do the same thing here, just do once here and grab this parameter interface, but we want to set a float value right here. And instead of passing a direct value, let me put in the name here as well. So crossfade was the name. So instead of setting a direct value, we want to pull off of this and say select float. And we want to select a float based on the Boolean. And we pass in this crossfade. If this is true, it'll be A. If it's false, it'll be B. So in B, we want to put 1, because remember that crossfade is between two values, 0 and 1. So now what we want to do is pass in this bad boy, just complete it to the set float. And then one time we'll go in here and we'll set this value to not itself. And basically this acts as a toggle. If you know anything, like, and usually people use like a flip-flop, but in order to toggle a value, you just need to set it to not itself, which is pretty clever. All right, so on the reset, all we want to do is, on the end overlap, all we want to do is reset this, and we're pretty much set up and ready to go when it comes to the crossfade. So let's go ahead and give that bad boy a test. You can see when we jump in here, it'll crossfade from the soft sound to the harsh soft sound. So let's press play. And now if we go back, it'll reset itself. And that's that toggle on and off. And And you can see how you can create some cool situations with the audio, man. So that's pretty much the quick start guide completed there for MetaSounds. If you found this video helpful, man, leave a like, leave a comment. Let me know that you want more of these quick start guides. If you're having trouble, getting through the text tutorials, I am more than happy to start creating more of these. Just let me know. Like I said, I started with MetaSounds because I am messing around with MetaSounds, so I want to reinforce my learning by teaching. So yeah, if you found this video helpful, leave a like, a subscribe, a comment. Let me know, man. I need to know. I appreciate you guys for watching, and I'll see you in the next one. Peace.